Hey, what's up, guys? Yeah, so this question is I come up with my own solution. So basically, this problem is very interesting that you start with the integer 1 and you want to reach your target, and you can increment by 1 or double the current integer. Okay, and you can use the increment operation any number of times. However, you can use double at most max double times. Okay, you return the minimum operations. For example, you want to start from 1 to 5. You can only 1 by 1 by target. And you start from, you want to get target 19. You can go to one initial ones and go to 4, go to 8, go to 9, go to 18, and go to 19. So there are 7 steps. For this, you get yeah. So previously, in the beginning, what I use is the what I come up with is the dynamic programming, and then I find dynamic programming cannot solve this problem. So okay, so let me just quickly say the dynamic. So the dynamic programming is that you create a dictionary, right? And then let's say RS means that you're at the target R, and then with the maximum double of S. If R is 1, that means you start at initial, so you just return 0. If S 0, that means that the max double is 0, right? So you don't have any way to do this. You can only return at R minus 1. And otherwise, you have 2 choices. Okay, so this is very simple, right? You got 2 choices, right? So if the is R is odd, then the only way is that it comes from R minus 1. Okay, if it's even, then there are 2 possibilities. It comes from R divided by 2, and use 1 maximum doubles, or it directly comes from R minus 1. Okay, so you got 2 ways. So if it's even, then I write DRS equals to minimum DFS, right? So this is whether you use 1 max doubles or you do not use. Otherwise, that if R is odd, then there's no way. You must come from R minus 1 and return this. And once I finish this code, I immediately find its time pass. Okay, so so which means that these problems cannot solve. The target is very hard. So this problem cannot solve by using the dynamic programming. Okay, so which comes the greedy algorithm, right? Because we know that the dynamic programming fail. Dynamic programming. Okay, so then the only way is the greedy. Okay, so the greedy is I just look at these 2 examples, and I think that I come up with the reason. I come up with the results. If its target is odd, then it must minus 1, right? So you go to 18. If target is even, then you can just divide it by 2. So you go to 9, and then 9 is odd, so divided by 1. Even divided by 2. Okay, so rule is this. So rule is that so if the target is odd, so target minus equal to 1. Okay, if a target is even, then the target equals to target divided by 2. Okay, and then you can initialize the answer to be 0, and for each step you just do this. Okay, and then there's a counterpart. There's a strange part is that if the maximum double is 0, then you immediately stop this loop and the plus target minus 1. Okay, so the same thing is target is 1, return 0, max double is 0, return target minus 1. Initialize answer. If target greater than 1 and the target is even, then if the max double, you can still use the double. Then you can minus target divided by 2 and the double minus 1 and the answer at 1. Otherwise, that means that you don't have any doubles. Then you can immediately use answer plus target minus 1 and break this loop. Okay. If a target is odd, then there's no way. The only way is target minus or equal to 1 and the answer plus 1 answer. Okay. So you can see that this is very fast. So this is the greedy algorithm that you can try to think of it. Okay. So the problem is that actually I cannot prove. I mean, it's not non-trivial, but you can try to prove that this is actually works. But the proof is, so I believe the proof is very non-trivial. Okay, hope you guys like this channel. See you guys.